Hello class, this is Mr. Bohorquez here. I want to thank you for tuning in to this digital lesson. This lesson is lesson number 1 for our number systems work. And this is going to be for the week of April 14th through April 17th. So, our lesson objective for this particular lesson is that we will be able to correctly find the sum or difference of positive and negative numbers. Notice these words sum and difference are underlined. We're going to talk more about that later. First, I want to give you guys a bit of an introduction to Edulastic. Edulastic is going to be where you can turn in and submit your work online if you're not using the physical packet picked up at school. To access the Edulastic assignment, first you go to your Google Classroom after you've logged in with your student ID number. Next, you're going to want to go to the Classwork tab. There you can find any assignments, either previous ones that we've already had in class, feel free to do those if you want, or any new assignments that's going to be coming up. Next, you're going to want to look for the Edulastic assignment, and these are going to be different every couple of weeks or so, so make sure that you're going to the right one, and the one that you want to go to for this week is number systems. Now, the cool thing about Edulastic is you can use that as a side website in order to do your work and submit your answers. And so you're going to want to answer your questions on the Edulastic website once you go to the link. However, when you are done with your assignment, make sure to mark as done on your Google Classroom assignment. That means you have to go back to Google Classroom and make sure you mark this assignment as done. That way it tells me on my end that you're done. Now, if you finish your work early, I recommend marking it as done early. That way I can take a look at your work and, if there's enough time, be able to turn that back to you, and perhaps you can get a higher grade than what you may have already gotten. For this video, we're going to go over a couple of new concepts as well as a couple of old concepts. So feel free to pause at any time or go back if you need something to be explained one more time. So, review. When we're talking about number systems, we want to remember that there are different types of number systems. These are number systems that we've seen before in our other classes, but maybe they weren't explained just how we're going to explain them right now. First, we have what are called the natural numbers. These are whole numbers, and the sign looks like this funny in here. Now, these natural whole numbers are countable. So those are numbers you can count on your fingers and toes, such as 1, 2, 3, 4, any positive number you can think of. Then we have the number system of integers, which looks like this funny Z here. Now, the difference between integers and natural numbers is that integers can have negative values instead of only positive ones. And there's 0. You see in the example, we can start from, negative infinity and then count negative 3, negative 2, negative 1, 0, 1, 2, 3, knowing that all the numbers to this side are going to be more negative and all the numbers to this side are going to be more positive. And last, we have our rational number system, which are better known to us as fractions. Now, fractions are numbers that have, two numbers, one on top and one on bottom. Those are called the numerator on top and the denominator on bottom. What's neat about fractions is that they can also be negative, such as, starting from some really big negative fraction here, going to negative 1/2, or 1 over 2, negative 1/4, or negative 1 over 4, 0, which technically is a fraction, I suppose, and then positive 1/4, or 1 over 4, positive 1 over 2. And it just keeps getting greater and greater and greater. We can see these number sets on the number line. Starting with the natural numbers, notice how our number line starts at 1, because that's the first number we can count to. And it keeps going positively 2, 3, 4, 5. Forgot that one, sorry. And then it keeps growing, just like that. Notice how these are also the only numbers it can be. 1, 2, 3, 4. No numbers in between. Only solid, whole, countable numbers. The next number set we can see here are integers, as denoted by this funny Z. Now, these numbers, notice how this arrow here says that on the number line, these numbers come in from, well, it keeps going and going and going and going. So we can imagine here that there's like a -5, a -4, -3, -2, -1, 0, 1, 2, and also it keeps going positively with this arrow, 3, 4, 5, all the way to infinity. Notice how our rational numbers here on our number line, as by this funny cue, well, there's 0 in there, and there's also a -1/4, a -1/2, a -3/4, and there's a -1 in here. So it can also be positive, and it could also contain integers, because, well, if you're dividing it by fourths, -1 is equal to -4/4. And then similarly on this side, we see that we have 0, 1/4, 1/2, 3/4, and +1. And that just keeps on growing and growing and growing as well. When talking about a number system of integers, we often like to use the word opposite when describing certain numbers. Now, the opposite of certain numbers is when you have a positive number, then the opposite of that positive number is a negative number, because the opposite of positive is negative. Same way, if you have a negative number, the opposite of that negative number will be positive. Not only will they be different signs, and when we're talking about signs, we're talking about positivity and negativity, they'll also be the same number. For instance, if we're looking at +1, the opposite of +1 is going to be -1. And one big reason why this is the opposite is because they're the same distance away from 0 on each side. They both have a distance of 1 away from 0. That's why they're the opposite. When you put these two opposites together, we get something called a zero pair. A zero pair is when you try to add two opposite numbers. We'll talk more about that in just a bit. Another thing with working with integers is that we have what's called absolute value. And what that looks like is two bars like this and a number right in the middle. Now, an absolute value determines exactly how far away a number is from 0. For instance, notice how we have the absolute value of -2. -2 is exactly 2 away from 0. Therefore, it has an absolute value of 2. Even though that this is a negative number, because that negative number is in between these two absolute value bars, that means that this negative number has an absolute value of 2. It is 2 away from 0. Notice in this example, we have a -2, but only the 2 is in the absolute value bars. Let's make sure we're not confusing that for 121, -121. So because the negative symbol is outside where the 2 is, that is outside the absolute value bars, this is still a negative value. Now this seems tricky, but it's important to know that the number inside the absolute value bars is what's negative. Because this negative number is outside, it stays negative. Another thing to notice about absolute value is how -2 is exactly 2 away from 0, and +2 is exactly 2 away from 0. And that is exactly why the absolute value of -2 is +2. I'd like you to take a moment to practice your new absolute value skills. Right now, I'd like you to evaluate the absolute value of the following. First, what's the absolute value here of -7 within the absolute value? The next problem is I have a negative and then an 8 within the absolute value, and I want to know what that answer is there. If you get done with those, I want you to try and solve these on the bottom. We have the absolute value of -3 plus the absolute value of -4. And we have the absolute value of 5 minus the absolute value of -3. Okay, I hope you've taken the time to pause the video, and now I've revealed the answers. To find the absolute value of negative 7, we just have to remember that this negative 7 is exactly 7 away on the number line from 0. Or we can also consider the fact that the negative is within the absolute value. So that gives us positive 7. On this question, we have the negative outside the absolute value. And even though 8 is 8 away from 0, because this negative is outside the absolute value, this remains negative and gives us an answer of negative 8. For these questions on the bottom, they took a little bit of more strategic maneuvering. We had to know that, well, negative 3 within absolute value gave us a positive 3. Negative 4 within an absolute value gave us a positive 4. So this just looked like positive 3 plus positive 4, which is a positive 7. Now in this problem here, we see that we have an absolute value of positive 5. Well, 5 is still 5 away from 0. In fact, we don't want to turn this negative because it's still 5 away. There's no negative on the outside, so there's no reason to keep it, just like in that one. So this remains positive 5. And then the absolute value of negative 3 turns into a positive 3, but we're subtracting those two numbers. So this turns into 5 minus 3, which is simply 2. Now, going back to the concept of zero pairs. Remember, a zero pair is any number that's both negative and positive, and you're trying to add them together. They're called a zero pair is because if you try and add these two numbers up, in this case negative 2 plus positive 2, that goes to 0. One way you can see this on your number line here is remember that all the numbers on this side of the number line are going to be more negative, and all the numbers going this side of the number line are going to be positive. If we start at negative 2, and we're going to add 2, that is go to the right 2 on our number line, 1, 2, you'll see that we'll end up right here at 0. And this helps us understand why this is a zero pair. In fact, we can even switch where these numbers are and have positive 2 plus negative 2. Now, these are the same things. We have the negative 2 on this side and the positive 2 on this side and the addition sign in the middle. So this should give us the same answer. In fact, if we start here at positive 2, we're going to add negative 2. Okay. Well, one thing to remember about negative is that it was the opposite. So if I were going to add 2 in this direction, well, I'd have to go the opposite direction. In fact, because we're subtracting it, really. You can rewrite this as 2 minus 2. And if we're thinking about like that, well, if we're, adding 2, but we're doing the opposite, we're subtracting 2. That's 1, 2. Back at 0. Thus confirming that if you have a positive number and you're adding it to a negative number, you get a zero pair. Another way that you can confirm that something's a zero pair is by doing this. You can, for some smaller numbers like these, put plus marks for 2's, or rather plus marks for positive numbers, and minus marks for negative numbers. We don't have to exactly put the number, but notice how there are 2 positives for positive 2, and there are 2 negatives for negative 2. These are zero pairs because for every negative, there's one positive. So they cancel each other out. Same thing here. This negative and this positive cancel each other out. And since they cancel each other out, poof, they equal 0. You can use either way to solve for any addition or subtraction of positive and negative numbers. For instance, we see here positive 5 plus negative 5. If we were to draw that on a number line, we have 0 in the middle, 1, 2, 3, 4, 5, and just for fun, we're going to do negative 1, 2, 3, 4, 5. So we're starting here at positive 5. That's our first term. And then we're going to add -5. Add. So if we're adding, we're going this way to the right. But remember, we're actually going that way because this is the opposite. -5 is opposite. This turns into 5 minus 5. So if we go here, 1, 2, 3, 4, 5. We're at 0. But let's double check that. I'm going to try with my 0 pairs. Let's see, I have 1, 2, 3, 4, 5 positives. And I'm going to add 1, 2, 3, 4, 5 negatives. So let's see. I added these. So there's a 0 pair. There's a 0 pair. For every one positive should be one negative. And how many do we have left? 0. So it makes sense. 5 plus -5 in two different ways gave us the answer 0. What if we have a more complicated equation like this one? +5 plus -8. Well, let's try and use our number line first. Let's start here at +5. And remember, we want to add -8. Whenever you hear negative, just remember you want to do the opposite. So if you're going to add, you're going to, instead of adding to the right, you're going to do the opposite and subtract to the negative. And we're going to go to the left, -8. 1, 2, 3, 4, 5, 6, 7, 8. Notice how we passed the 0. I mean, I guess that makes sense because the absolute value of 8 is, -8 rather, is greater than 5. So we're going to go past that. And we got this value. It looks like a -3. Well, to double check that, let's try and doing our positives and minus signs here. So we have positive 1, 2, 3, 4, 5. The negative 1, 2, 3, 4, 5, 6, 7, 8. Well, then I have 1, 2, 3, 4, 5 0 pairs. And then I'm left with these 3. These 3 negatives. So using my 0 pairs, this has got to be -3. So it checks out. By using the number line, if we start at 5 and go to the left, -8, we're adding -8 or subtracting 8, we get -3. And if we use our 0 pairs like this, we see our 5 positives and 8 negatives. There are more negatives than positives. Because there are more negatives than positives in this particular equation, we're going to get a negative answer. Another neat way to see this is if you separate both numbers into a positive and a negative column like this. Notice how 8 is the larger of the two. We have -8 and +5. Since 8 is the larger number, we're going to move that 5 over here to the negative column. And then we want to do, well, this equation like this, 8 minus 5. 8 minus 5 is 3. And because this is in the negative column, this is going to be -3. Just another fun way to try and understand how to express and answer these problems when you have positive and negative numbers. On this particular question, it's asking us to evaluate -6 plus -2. Well, on the number line, we can start out at -6, which is our first term, right here. And remember, we're adding -2. So add, if we were to add, we'll go this way, subtract, we'll go this way. But again, that negative means that we're doing the opposite. The opposite. And, well, the opposite of addition is subtraction. So if we were to start here at -6 and we're going to do the opposite of adding, we're going to go 1, 2, right here at -8. Okay, well, that's a bit strange, but let's continue. Let's try with our algebra tiles, or rather our positive and minus tiles. So we have 1, well, no, this is a -6, so we need 1, 2, 3, 4, 5, 6 negatives. Now we're going to add 2 more negatives, so that means we're going to put 2 more negatives there. Okay, so our grand total here is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 negatives, which is exactly what we got on the number line. -8. what we should gather here is, because this is a negative 2 and negative means opposite, this is basically like saying negative 6 minus 2. And since you're subtracting that 2, you're going to the left 2. That's exactly what's going on. 6, 7, negative 8. Negative 6, negative 7, negative 8. Now we have an equation that's a little bit different from the other ones. It's asking us to find 4 minus negative 3. Well, if we start on the number line at positive 4, that's going to be right here. And it wants us to subtract negative 3. Well, let's see, this is different now. If we're subtracting, we'd want to go to the left. But this is negative. And remember, whenever we see negative, we want to do the opposite. So if we would normally go this way to the left for 3, since we're doing the negative, we're going to the right 3. 1, 2, 3, which gives us a positive number, positive 7. That's a little interesting. Maybe we can confirm this with using our plus and minus tiles here. If we have 1, 2, 3, 4 positives, and I want to take away 3 negatives, we want to subtract 3 negatives. We're finding the difference here. Well, we don't have 3 negatives to take away. We have to do something in order to put 3 negatives there to take away. What if we can use the idea of a zero pair to help us out here? For example, well, we don't have a negative 3 to take away. I don't have any negatives to take away here. What I could do is add some zero pairs to where there are 3 negatives. Now, these themselves represent 0. That's a 0, that's a 0, and that's a 0. But now I have these negatives to work with. Now we can subtract, take away 3 of them. If we were to subtract or take them away, we're left with only positives. 1, 2, 3, 4, 5, 6, 7 to be exact. So just like how we found positive 7 here, using our number line, we had positive 7 in our kind of new interesting way to subtract negative numbers. So that ends up being a positive 7. And lastly, one thing to realize is that when you see subtracting a negative, that is just like turning this into a positive. Well, makes sense. 4 plus 3 is 7. That's because when you're doing the opposite of subtraction, it basically turns into addition, because that's the opposite. So if this was a negative 3 and you're doing the opposite, you're just adding 3, which gave us 7. For our last example, we're going to evaluate the equation negative 7 minus negative 7. Well, let's see here. If we're going to start at negative 7, there's a lot of numbers, so I just here's negative 5, 6, negative 7 here. And we're going to subtract negative 7. Well, we're doing the opposite of subtract. We're adding, because remember, this is negative, and the opposite, when you have a negative, it's opposite, and the opposite of subtraction is addition. So we're actually going to go this way, 7. 1, 2, 3, 4, 5, 6, 7. And we get 0. That's interesting. Doesn't look like a zero pair. Well, let's try our positive and minus tiles. 1, 2, 3, 4, 5, 6, 7 negative tiles. And we're going to take away or subtract 7 negative tiles. Huh. All 7 are gone, and we're left with none. 0. So I guess that makes sense that this would be 0, just like we found on the number line. So if we were to break this down, if we had negative 7 plus, or rather minus a negative, well, these two are opposite, so this is going to turn into a plus. There is our 0 pair right there. Negative 7 plus 7 is 0. And that's because we have a negative and we're subtracting another negative. And that turns into a positive, and since it happened to be, well, 7, well, they turn into a 0 pair. Now, I want you guys to try and do this one on your own for now. First, I want you to evaluate using a number line or 0 pair. So either the number line like we did before or using your plus or minus tiles. I want you to find what is 7 plus negative 10. At this time, you may pause the video, try and do your own work, and then start it up again, press play, when you think you got an answer. Okay, so hopefully you've done your work and you've tried to evaluate this equation right here using either a number line or the 0 pairs. I wrote down my number line, so let's see how we can tackle this problem using this method. Well, again, we want to start at positive 7 because that's the first number in our equation here, first term. And we're going to add negative 10. Well, remember that these two signs here turn to opposite. And if the opposite of addition is subtraction, we're going to go 10 this way to the left. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like it's giving us a negative 3. Okay, let's try it using our 0 pairs. We have 1, 2, 3, 4, 5, 6, 7 positives. There we go. And we need to add 10 negatives. So it means we're going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negatives on the board. First, we have to see how many 0 pairs we have. That's a 1, 2, 3, 4, 5, 6, 7. And we're left with also negative 3. So this must be negative 3. Again, another neat fun way is if you had, I should say, well, not here, but if we had 7 in our positives and 10 in our negative column here, so this is 7, this is 10. We see that 10 is the bigger number of the two. We can move that 7 there. 10 minus 7 is, well, that's 3. And because this is in the negative column, it's negative 3. Isn't that neat? So there are a couple of things we want to do as we wrap up key ideas from this first lesson on adding and subtracting integers. First, we want to remember that negative, in an easy way, is just the opposite of something. So if you have a negative number, that's the opposite. So if you had negative 3, the opposite would be positive 3. And if you had positive 3, its opposite would be negative 3. If you had negative 5, its opposite would be positive 5. And if you had positive 5, its opposite would be negative 5. Also, that a 0 pair is when you add two opposite numbers. So if we wanted to add negative 4 to positive 4, it gives us 0. And if we wanted to add, well, in this case, positive 6 to negative 6, we'd get 0. Also, remember that absolute value is the distance from 0. So if you have a number within absolute value, even if it is negative, it's going to be a positive number. So the absolute value of negative 7 with the negative inside the bars, the absolute value bars, is positive 7. But if you had a negative outside the absolute value bars, then that's going to remain negative. And just for clarity, if you had a positive inside the absolute value bars, it's still positive. It doesn't change the negative. More key ideas is to remember the sum is when you're adding numbers. So when you're adding numbers, you're finding the sum. And the difference is when you're subtracting numbers. So when you're subtracting numbers, that's just called the difference. You can use the number line to help you solve for your sums and differences with 0 in the middle. Positives on the right side, negative goes to the left side. Unless you're doing the opposite, of course. Or you can use your plus and minus tiles, like so, and determine how many 0 pairs you have like this. Some more key ideas to get out of this lesson is that when you're adding two positive numbers, well, it makes sense. You're going to get a positive number. Adding positive gives you positive, like if you had 2 plus 7, give you a positive 9, like we've been doing before. If you're adding two negative numbers, well, that's going to give you a negative number. So like if you had negative 3 and you're going to add negative 5, well, you're just taking away more. You have more negative, so that gives you a greater negative. You're adding more negativity, and that's just more negative. if you were going to subtract two negative numbers, well, it might give you a positive number if the second number has a bigger absolute value. And what we mean by that is if you had a number like, say, -3 minus -4, and you can check my math on this, since -4 has a greater absolute value, this is like -3 plus 4, which is going to give us 1. And if we have this number here, well, -3 minus -2, well, -2 doesn't have as large as an absolute value as -3. So, again, check my math. -3, and that's going to be, well, plus 2 because a minus and a negative is positive. Well, that's still -1. And that about wraps up everything we want to talk about in this first video. So again, guys, I want to thank you for watching our number systems. This is video 1 for adding and subtracting integers. Make sure to keep an eye out for any upcoming videos. The next one's going to be video 2 number systems, multiplying and dividing integers. Okay, so I want you guys to stay safe, and thank you for watching. Have a great day. See you next time.